In this video, we are going to look at two other ways to make solutions. The first one is called mass percent, and the second one is called mole fraction. Let's first look at mass percent or percent mass. So mass percent, this is taking the mass of the solute and dividing it by the total mass of the solution. And by mass, we mean grams. So we'll have grams on top and grams on the bottom, and then we'll multiply by 100 to get that percent. So let's look at our first example. So if I have 5 grams of NaOH and I add it to 95 grams of water, what is the mass percent? So I can find the mass percent of both the NaOH and the water. So let's find both. So in the problem, if you're not told which one to find, then you should find all of them. So let's first start with NaOH. So the total mass of my NaOH divided by the total mass of my solution. So that would be 95 plus 5. That does give us 100. I tried to make this really easy. So I end up with 5% of my NaOH. So you can, for the water, just subtract it from that 100%. So I know I'm going to get 95% water, but you also could work it out. So 95 grams of the water now divided by that 100 grams total, which we solve for there, and multiply by 100. So in this problem, 5% mass will be by NaOH and 95% mass will be our water. All right, now let's look at mole fraction. So in mole fraction, even though the name says mole fraction, the answer is actual decimal point. So of some value, less than 1. So the answer is a decimal, it's not a fraction. So even if you have to divide 3 divided by 5, that's not your answer, 3/5. You actually need to divide it out and have a decimal for an answer. So for this, just like that percent mass, you can find both the solute and the water. And again, if they don't ask, you should find both. So let's look at this one. So my problem is right down here. What is the mole fraction of the sugar and the water in a solution with 5 moles of water and 1 mole of sugar? So the difference between this one and the mass percent is we need to be in moles for this one. So now we're comparing moles. And then we don't multiply it by 100, we just leave it be. So leave it as a fraction. So let's start off with our sugar. So we want the total moles of our sugar, which is 1 mole. So 1 mole on top of my sugar, and I'm going to divide it by the total moles of everything. So I have 5 moles of my water and 1 mole of the sugar, so that would be 6. So my answer is going to be 1 divided by 6, or 0.167. So there's 3 sig figs, that's plenty. So notice that there are no units because I end up having moles divided by moles. So this is my answer for the sugar. Let's go ahead and look at the water. So I could take that 0.167 and subtract it from 1 to find out what the water is, or I could just figure it out. So 5 moles of the water divided by my total moles, which we know is 6. And so I get 5/6, and my answer is 0.833. So again, find the sugar, find the water. This is called mole fraction, but it's not a fraction, it's a decimal. So let's do one more example. So in this example, our values are given to us as grams, and so I would need to convert them to moles first in order to solve for that mole fraction. So let's go ahead and look at the NaOH. So in my sodium hydroxide, I get 10 grams, and I'm going to add up on the periodic table all the molar masses, and I'll add these up, and I'm going to get 40. So this goes down below because in order to cancel out, one has to be in the top, one has to be in the bottom, or diagonally placed. And so I do 10 divided by 40, and I'm going to get 0.250 moles of my NaOH. And then this is mixed together with my water, and my water I need to divide by 18. So 500 grams of my water, and for water, 18 grams is equal to 1 mole. So adding up 2 H's and an oxygen gives us 18. And let's divide, and we get 27.8 moles. So let's go ahead and do the mole fraction. So for the NaOH, I'm going to take 0.250 moles and divide it by my total moles, which is 28.05 moles. And I get as my mole fraction 0.00891. So again, to find my water, I could just take this answer and subtract it from 1, or I could just figure it out. So my water, I'm going to have the 27.8 on top, and on the bottom, the 28.05. And I get 0.991. So for the NaOH, just a really, really small fraction, and for the water, that's what most of the solution is.